So here we have a trigonometric function. We need to determine its limiting value when x approaches a non-zero quantity, that is pi over 2. So this can be rewritten as limit h tending to 0, 1 plus cosine of 2 times pi over 2 plus h divided by pi minus 2 times pi over 2 plus h whole square. So we'll have limit h approaching 0, 1 plus cosine of, we'll multiply the 2 to pi over 2 plus h, so that will give us pi plus 2h divided by pi minus 2 times pi over 2 will be pi minus 2 times of h squared. So we have limit h approaching 0, 1 plus the cosine of pi plus 2h. So this is in the third quadrant. So we're going to use cosine of pi plus theta is equals to minus of cosine of theta. So that means here we'll have 1 minus cosine of 2h divided by, so the pi and pi gets cancelled, so we have negative 2h whole squared, so that will be 4h squared, which will be equals to limit h approaching 0. So 1 minus cosine of 2h will become 2 sine squared 2h over 2, so it's simply going to be h divided by 4h squared. So we'll have now, so 2 times 2 is 4, so we have half times the limit h approaching 0. Sine square h can be written as sine h over h times sine h over h. So when we find the limiting value of the two functions, sine h over h, so per definition this is 1, so that will give us half times 1 multiplied to 1. So the limiting value of the given trigonometric function when x approaches pi over 2 is going to be equals to half. Let us do another problem. So here we have the function given by sine x minus cosine of x divided by x minus pi by 4. So we have to determine its limiting value when x approaches pi by 4. Now we want to do a direct substitution for the value of x. We have sine pi by 4 minus cosine of pi by 4. Now sine pi by 4 is 1 over root 2. Also is the value, also 1 over root 2 is the value of cosine pi by 4. So that means we have a 0 in the numerator, and we'll have pi by 4 minus pi by 4, so that will give us 0 in the denominator. So this is having an indeterminate form of 0 over 0. And also our limiting value needs to be calculated at when x approaches some non-zero value, that is pi over 4. So what we're going to do, we're going to change the limit from x going to pi by 4 to h going to 0. So that means we have to replace x by pi over 4 plus h minus cosine of pi over 4 plus h divided by, now x will be pi over 4 plus h minus pi over 4. So the pi over 4 and pi over 4 gets cancelled. That will leave us with h in the denominator. Now we are going to use the identity sine of a plus b is equals to sine a times cosine of b plus cosine of a times sine of b. So you're going to use this identity to expand the first term in the numerator, which is sine pi by 4 plus h, and we'll use the identity cosine of a plus b equals cosine of a times cosine of b minus sine of a times sine of b. And we're going to use this identity for our second term in the numerator. So that will give us now limit h approaching 0. So we have sine, a here is pi by 4 and b here is h. So we have sine a times cos b plus cos a times sine b minus so we have cosine of pi by 4 times cosine of h. Now we have minus of sine, so that gets multiplied with a negative sign to give us a positive. Sine pi by 4 times sine h whole divided by h. Now we know sine pi by 4 is 1 over root 2, so we have limit h approaching 0, 1 over root 2 times cosine of h plus cosine of pi by 4 is also 1 over root 2, so we have 1 over root 2 times sine of h minus 1 over root 2 times cosine of h plus 1 over root 2 times sine of h whole divided by h. So 1 over root 2 cosine of h and negative 1 over root 2 cosine of h cancels each other. So now we are left with 2 times root 2. So there are 2 of them, 1 over root 2 sine, so they get added. So we have 2 over root 2. So that being a constant, I'm bringing it to the front of the limit. So we have limit h tends to 0, sine of h over h. So as per definition, the limiting value of sine of h over h is going to be 1. So we have 2 over root 2. And if we rationalize the denominator, that is going to give us square root of 2. So this is the limiting value of the given function, trigonometric function, when x approaches pi over 4. Let us do another problem. So we need to determine the limiting value of the given function when x approaches pi over 2. So let's change the limit of x. So we have limit h tending to 0, 1 minus sine of pi over 2 plus h divided by pi over 2 minus of pi over 2 plus h whole squared. Now we know that sine pi over 2 plus h will be equals to, now this is in the second quadrant, it's 90 plus theta, so that sine will change to cosine, so we'll have cosine of h. Since in the second quadrant sine is positive, so we'll have positive cosine of x. So that function will now become limit h tending to 0, 1 minus cosine of h divided by, so the pi by 2 gets cancelled, and we have negative h whole squared, so that will be simply h squared, which is equals to limit h tending to 0. So 1 minus cosine of h will be 2 times sine squared h over 2 divided by h squared. So let's rewrite it. So we'll have limit. So let's bring the 2 to the front, it being a constant. So we have limit h tending to 0. We have sine h over 2 divided by h times sine h over 2 divided by h. Now we need an h over 2 in the denominator, so that means we need to multiply by half. Similarly, we also need an h over 2 over here, so that means we are going to multiply the entire function by half. So that will be 2 times 1 over 4, so half times half is 1 over 4. Now we apply the limiting value to each of the functions. So by definition, sine h over 2 divided by h over 2 will have a limiting value of 1 when h approaches 0. So we have 2 over 4 times 1 times 1. So this is going to give us a limiting value of half. Let us do another problem. So here we have a trigonometric function. We need to determine the limiting value when x approaches pi over 6. If you do a direct substitution for the value of x, you'll get the indeterminate form of 0 over 0. So what we're going to do here is we are going to simplify this given function. So here we have limit. So we're going to change the limit from x to h. So we have h tending to 0, 2 minus square root of 3 times cosine of x. This is going to be h plus pi over 6 minus sine h plus pi over 6 whole divided by 6 times pi, 6 times h plus pi over 6 minus pi whole squared. So we're going to expand sine h plus pi over 6 and sine h plus pi over 6 using the identity cosine of a plus b and sine of a plus b. So we have limit h tending to 0, 2 minus square root of 3 times cosine of a times cosine of b minus sine of a times sine of b minus sine a times cos b plus cos a times sine b whole divided by, so we have 6 times h plus 6 times pi over 6 will be pi minus pi whole squared. So the pi and pi gets cancelled. So now we will have, we'll need some more space here. So this will be equals to limit h tending to 0, two minus square root of 3 times cosine of h times cosine of pi over 6 is 30 degrees. So cosine of 30 degrees is square root of 3 over 2. So we have minus root 3 multiplied to negative sine h. So that will be positive square root of 3 times sine h. And we have sine 30 degrees. So sine 30 degree is half minus sine h times cosine of 30, which is root 3 over 2, minus cosine of h times sine 30 degree, which is half, divided by 6h whole square, so that will be 36h squared. So this is the third term is square root of 3 over 2 times sine h, and we have root 3 over 2 times sine h, so it's a negative 1, so they're additive inverses of each other, they will cancel out. This leaves us with limit h tends to 0, so we have a 2 here, minus, so root 3 times root 3 over 2 is going to be 3 over 2 cosine of h, and we have negative half cosine of h whole divided by 36h squared, which will be equals to limit h tending to 0, 2 minus, so we have 3 over 2 added to half, so that will become, so we have 3 over 2 plus half times cosine of h divided by 36h squared. So that will give us limit h approaches 0, 2 minus, so 3 over 2 plus half is going to be 4 over 2, so that is simply 2. So we have 2 times cosine of h divided by 36h squared. Now we're going to factor out 2 from both the two terms. So we have 2, and we also take out 1 over 36, which is a constant. So we have 2 over 36, limit h tends to 0. So we have 1 minus cosine of h divided by h squared. So we have 2 over 18. So limit h tends to 0. Now 1 minus cosine of h can be rewritten as 2 times sine squared h over 2 divided by h squared. So we'll have 2 over 18 times limit h tends to 0. So we have sine h over 2 divided by h times sine h over 2 divided by h. So we're going to divide the denominator h by 2, meaning we'll need to multiply by half, times, so we also have to divide this h by 2 and multiply the function by half. So we'll have 2 times 18 times 4. So we have, let's write it as 18 times 2 times 2 times, then the limit h tending to 0, sine h over 2 divided by h over 2 times the limiting value of sine h over 2 over h over 2 when h tends to 0. So this will give us the 2 and 2 gets cancelled. So we'll have 1 over 18 times 2 is 36. And the limiting value of sine h over 2 divided by h over 2 is going to be simply 1. So this is the limiting value of the given function when x approaches pi over 6. So we need to determine the limiting value of the given function when x approaches pi over 6. So what we're going to do here is we're going to use a slightly different method here before changing the limit from x to h. So we are going to do a little bit of manipulation here. So we are going to multiply and divide the numerator by 2. So we have 2 times square root of 3 over 2 times sine x minus half the sine of x divided by x minus pi over 6, which will be equals to limit x approaching pi over 6 2 times, so square root of 3. So instead of writing square root of 3, we can rewrite it as cosine of pi over 6 times sine of x minus half can be replaced by sine pi over 6, then sine 30 degrees times cosine of x divided by x minus pi over 6. Now the numerator is of the form sine a cos b minus cos a sine b. So this is equals to sine a minus b. That means we have limit x tending to x over 6 2 times of sine x minus pi over 6 divided by x minus pi over 6. Now we are going to change the limit. So we have limit, so let's bring the 2 to the front. So we have limit h approaching 0. So we have sine pi over 6 plus h minus pi over 6 divided by pi over 6 plus h minus pi over 6. So the pi over 6 gets cancelled, both the numerator and the denominator. Now we are left with 2 times the limiting value of sine h over h, and we know by definition the limiting value of sine h over h is 1. So the limiting value of the given trigonometric function, this particular trigonometric function when x approaches pi over 6 is going to be equals to 2.